An assembly is really nothing more than a binary that's created by a .NET compiler. Of course, planning assemblies takes a little bit of time and effort, but when you plan them correctly, you can really control things such as the scope, the visibility, instantiation of their containing classes. Now, the binaries are organized either as an exe or a DLL, but no matter which they are, whether it's an exe or a DLL, you know that the contents of the assembly basically is nothing more than Microsoft Intermediate Language instructions. So the assembly also creates a completely self-describing metadata manifest. And this is very similar conceptually to IDL and COM, except it's actually much more verbose and much more complete than what we would find using IDL. So when we distribute our applications in .NET, what we're actually distributing are our assemblies. Now, since the assemblies contain Microsoft Intermediate Language, this is also an important concept to understand. Remember that the Microsoft Intermediate Language really is the instructions that are created by the .NET compiler. The .NET compilers that we use have to adhere to the Common Language specification. So the Microsoft Intermediate Language really is the result of adhering to that Common Language specification. All .NET languages will basically compile to the same IL. Now, there might be a little bit difference depending on the compiler exactly what type of intermediate language you get in terms of how particular tasks are physically completed and executed. But really, we end up with pretty much the same intermediate language no matter what compiler we use, whether it's a VB.NET compiler or a C# compiler. Now, the intermediate language is actually processed by the Common Language Runtime. Remember that IL is not machine code. So the Common Language Runtime is responsible for doing all of the compile on demand, if you will, of the intermediate language. It's the responsibility of the CLR to convert that intermediate language to underlying machine code. So in this way, if you're familiar with the Java programming concept, it's very similar to the concept of Java bytecode. The big difference, really, though, between the intermediate language and Java bytecode is that .NET currently targets only the Windows platform, where obviously with Java bytecode, as long as you have a Java virtual machine that runs on a particular platform, technically the same bytecode could run on any platform. There is, however, no restriction that says that the .NET Common Language Runtime can only run on Windows. Theoretically, it would be possible to create IL-compliant Common Language runtimes that could run on other operating systems. That is theoretically possible. Another kind of interesting distinction between what's happening in the Java world and what's going on with .NET is that bytecode in Java can only be created with the Java language. There really is only one way to manufacture bytecode. That's write Java code and then use the Java compiler. Well, with .NET, as we know, we have a number of different .NET languages that we can use. We can take our choice and then use the compiler that's provided for that language that gives us the same intermediate language result. So in that way, we have a lot more flexible implementation in terms of language and interoperability between languages, more than we might get in the Java world.